So good evening all of you. Today we are going to do the types of chemical reactions in detail. So the first type of chemical reaction is combination reaction. So I told you combination reaction is of three types. The first one is when element combines with an element. The examples we did, magnesium is an element combining with another element, that is oxygen, to give what? MgO. C plus O2 gives what? CO2. The second type is when a compound combines with element to give a single product. So what is it? C plus O2 gives CO plus O2. CO is what? A compound. What is it? Carbon monoxide. And they give a single product. That is why this is known as combination reaction. The last one is where a compound combines with a compound to give a single product. And the example is, this example will be repeated n number of times. So example is quicklime. When dissolved in water, what happens? Slaking of lime takes place. The lump slakes. The first observation is lump slakes. Slakes का क्या मतलब है? बिखरना. Second, hissing sound. Second observation is hissing sound. And the third observation is that it is an exothermic reaction. So the temperature of the container will rise and you can see the bubbles. Okay. And now this was what? This was quicklime. And this is what? Slake lime. Where do we use slake lime? What is the day-to-day relevance? That it is used in whitewashing. Take it. And why do we get a shiny white finish after 2-3 days of whitewash? Because the slake lime, it reacts with atmospheric carbon dioxide to make CaCO3 plus H2O. And the CaCO3 is the formula of marble, which will give a shiny white finish. So, combination reactions, first of all you need to know the definition that when two or more reactants combine to form a single product, right? The reactants can be, element can combine with an element, or compound can combine with an element, or compound can combine with a compound. But the condition is that the product should be single. Then it will be categorized as combination reaction. You may be given various reactions and you may be asked to identify the type. So whenever a single product is formed, then it is always called what? Combination reactions. So now let us come to the next one, that is decomposition reaction. So decomposition reaction is when a single reactant breaks down into 2 or 3 products, right? So decomposition reaction is of classified into 3 types. What is the definition? When the single reactant breaks down into 2 or 3 products on the application of heat, light or electricity, right? So when the single reactant is breaking down in the presence of heat, they are known as what? Thermal decomposition. Thermal word stands for heat, right? When the single reactant breaks down in the presence of sunlight, then it is known as photolytic decomposition, right? And when the single reactant breaks down in the presence of electricity, then it is known as, then it is known as electrolytic decomposition. Okay, lytic, the word lytic means to break down, photo means sunlight, electro means electricity, and lytic means breaking down. So breaking down in the presence of what? Electricity will be called electrolytic. Breaking down in the presence of what? Sunlight is going to be called what? Photolytic. So this is the way we categorize them as decomposition reactions. So the thermal decomposition reactions, there are 3 examples. The first one is calcium carbonate on heating gives calcium oxide plus CO2, right? The second one is PbNO3 whole twice, which is a white crystalline salt on heating. This triangle we make for heating, on heating makes PbO. PbO is what? A yellow residue plus NO2. NO2 is a gas which comes out through brown fumes, right? And O2. And what is the observation? First observation is what? You get a crackling sound. जैसे पटाखे बजते हैं तब आवाज नहीं आती है, बिल्कुल वैसे. You get a crackling sound. And the second observation is you get a yellowish brown residue. And the third observation is you get a brown fumes of NO2. Right? So this was the second example of thermal decomposition reaction. Now the third example is heating of ferrous sulfate. Ferrous sulfate has got, remember, the number is very important, that it has got 7 molecules of water attached to it. Dots say what do we show? That these water molecules are attached to it. And when these water molecules are attached to it, they impart a color. So what is the color? Green color. So on heating, these water molecules evaporate, they leave the crystal lattice and the salt becomes what? White. Plus 7H2O. So now the color of this left out salt is what? White. If you further heat this salt, FeSO4, then you get Fe2O3 plus SO2 plus SO3. Fe2O3 is also the formula of rust. So if it is a formula of rust, the color is going to be reddish brown. So it is a reddish brown in color, right? And these two gases have smell of burning rubber, right? So 3 examples are clear to everyone. First is heating of calcium carbonate. Second is heating of lead nitrate. And third is heating of ferrous sulfate, dot 7H2O. So in this, white crystalline salt on heating gives a crackling sound, a yellowish brown residue, brown fumes of NO2 and O2, right? And a green colored salt, that is FeSO4.7H2O, on heating gives FeSO4, which is a white solid, right? As soon as the water of crystallization evaporate, the color becomes what? White. And on further heating, it turns out into what? Reddish brown, and SO2 and SO3 are released, which are colorless gases. They don't have any color, but they have smell of burning rubber. So I hope it is clear. Thermal decomposition is clear to all of you. Now let us move to the next, that is photolytic decomposition. So I'm rubbing this out. Thermal decomposition I'm rubbing. I'll be sending you the notes. So now photolytic decomposition means single reactant breaking into two or more in the presence of sunlight, right? So we have got two examples for this. First is AgCl. AgCl is a white salt. AgCl is also silver. Ag is a symbol of silver and Cl is chloride. The valency of Ag is +1 and Cl is -1. So the formula becomes what? AgCl. So in the presence of sunlight, how do we denote? Either you write sunlight over here on the arrow or you write Hν. Hν denotes photons and photons represent sunlight. So in the presence of sunlight, it breaks down into Ag and Cl2. Now remember one thing, that here it is a metal. So it will be kept in monoatomic state, and chlorine is a non-metal. So it will be written according to its atomicity, that is 2. Right? Chlorine is a pungent smelling, pungent means a very bad smell which we don't like to smell, and yellowish green gas. What is the color? It is yellowish green gas. And silver is left out as a grey powder. So I told you all that the observations are very important. AgCl is a white salt. On keeping in sunlight, chlorine evaporates as a pungent smelling yellowish green gas and left out powder is grey colored silver. Similarly, another example is AgBr. Both the silver salts are photolytic, but this was white in color. This is light yellow in color. Again, on keeping in sunlight, it breaks up into Ag and Br2. Is it okay? So this was light yellow. Ag's color is what? Its color is grey. It's a metal. It will be kept in a monoatomic state. And Br is bromine is what? Non-metal. So it will be kept as according to its atomicity, that is 2. And it is going to evaporate as reddish brown gas. So is it clear? Now though I am going to give you, this is going to be followed with a worksheet of questions, but then the questions are going to come like this. A white salt kept in sunlight turns grey and gives a pungent smelling yellowish green gas. Identify the salt, identify the grey substance and identify the pungent smelling yellowish green substance. Right? Similarly, AgBr, it's a light yellow colored salt kept in sunlight turned grey, releasing a reddish brown gas. So identify the salt, identify the grey colored compound and identify the reddish brown gas. Moreover, both AgCl and AgBr are used in black and white photography, right? So in the question they can give you an indirect hint also that a compound, a light yellow colored compound used in black and white photography, when kept in sunlight turns grey and gives out a reddish brown gas. Identify the compound, identify the grey substance and identify the reddish brown gas. So is it okay with everyone? If this is okay, then we are going to move with the next important decomposition reaction, that is electrolytic decomposition. And mind it, all the 3 types are very important in this chapter because they have got number of observations and number of hints. So you need to learn them by heart. Rather, I would tell you, just practice writing them 2 to 3 times. Right? So I am rubbing this. This will be followed by notes. So now I am explaining you electrolytic decomposition. Electrolytic decomposition, we need to perform an activity for this. Let us take a plastic mug, drill 2 holes and fit 2 electrodes in it and attach them with a battery. and a switch like this. And in this plastic mug, what you can do is you can fill water H2O with few drops of dilute H2SO4. Is it okay? Now, the electrode, these are the electrodes. The electrodes which is connected to the negative terminal of the battery. The smaller line is what? Negative terminal of the battery, and the bigger line is what? The positive terminal. So, the electrode which is connected to the negative terminal of battery is always called cathode. What is it called? Cathode. And the electrode which is connected to the positive terminal of the battery is known as what? Anode. What is it known as? Anode. So this thing you need to remember, because not only this, there are 5 electrolytic processes in the entire syllabus of chemistry this year. And the first and the foremost thing which a child needs to remember is that cathode is the one which is attached to the negative terminal and anode is the one which is attached to the positive terminal. Now see, what happens is we have put water. Pure water is a very poor conductor of electricity. That means it does not break down into ions so easily and does not conduct electricity. Because electricity can be conducted only by 2 things, either ions or electrons. So if water is not going to break down into ions, it cannot conduct electricity. But if we add few drops of dilute H2SO4, this dilute H2SO4 increases the conductivity of water. So one of the questions which can be asked is, why do we add few drops of dilute H2SO4 during electrolytic decomposition of water? So what is the answer? The answer is to increase the conductivity of water. As pure water is a poor conductor of electricity. Now conductivity is increased by ions, that means water was what? Ionizing. So when water ionizes, it gives 2 ions, H plus and OH minus. And if all of you remember, in class 9 we did that positive ions are also called cations. Do you know why do we call them cations? Because cations in a circuit, they move towards cathode. Can you relate with it? Cations. Cathode. So cations are always going to go to cathode. So cathode pe who is going to come? H plus is going to come. And anions, negative ions are called anions, and anions are going to go to anode. So OH minus will go to what? Anode. See, whenever the ions come to the electrodes, they lose their charges. So how will they lose their charges? They will lose their charges. Suppose this is a positive charge cation. It can lose its charge if it accepts an electron, right? So at cathode, as it is connected to the negative terminal of battery, so it has got abundance of electrons. So hydrogen H plus ion is going to accept electron and make H. 2 H atoms will combine and form what? Hydrogen gas. So what can we do? एक inverted test tube हम इसके ऊपर लगा देते हैं, so that जो भी hydrogen gas evolve होगी वो इस test tube के अंदर collect हो जाएगी. Is it clear? Similarly, OH minus ions were the anions which went to anode. So they go to electrode to lose their charge. So here anode is deficient of electrons because it is connected to the positive terminal of battery. So these anions will lose their electrons here. So OH minus is going to lose its electron here, right? And get converted into OH. 4 such OH will reassemble to form, water and O2. This is a bit complicated. OH minus ions, they lost their electrons and made OH. 4 such OH, they reassembled and made water and oxygen. Water will go back into the electrolyte and oxygen can be collected by putting an inverted test tube over here. So is it clear? Finally, what we need to remember in short is that at cathode H2 is released and at anode O2 is released. So the second question asks, name the gases released at cathode and anode. So cathode pe who was coming out? H2 and anode O2. Right. See, here it was gaining an electron. Gain of electron is also called reduction. And you can remember by a mnemonic CAR. What does CAR stand for? CA stands for cathode and R stands for reduction. And what does reduction mean? Reduction means, this is what reduction, and reduction means gain of electrons. Okay, so always remember cathode पर क्या होगा? Reduction होगा. Reduction का क्या मतलब होगा? Gain of electron होगा. So we'll start from here. H2O was not breaking up into ions, but when you had put few drops of sulfuric acid, it broke up into ions, that is H plus and OH minus. H plus having positive charge on itself is called a cation, and OH minus having a negative charge on itself is known as anion. Cation is going to go to cathode. Cathode means CAR. CAR means cathode per reduction. Reduction means gain of electron. So they go to the electrodes to remove their charge. So what will they do? How will they remove their charge? H plus is going to gain a electron because electron is what? Negative charge. जो plus minus they will neutralize themselves. So यहाँ पर क्या आ जाएगा? H आ जाएगा और दो H मिलकर they will make what? H2. Is it okay to everyone? Similarly, the anion OH minus ion is going to go to anode. Anode पे जाकर it is going to lose electrons. Their gaining of electrons was taking place. So here losing of electrons will take place. ठीक है? They will lose electrons and it is going to make OH. 4 OH will reassemble to make 2 H2O and O2. Most of the schools, they don't focus on equations taking place at cathode and anode. But why did I tell you? Because this makes learning permanent. Permanently you can remember what will happen at cathode and what will happen at anode, because 5 electrolytic processes are there this year. So every time we cannot cram. Right? Now the third question is, the gases will collect like this. यहाँ तक पानी आ जाएगा और ये जो ऊपर वाला area है यहाँ पर gases होंगी. So what you will notice is that the amount of hydrogen collected is double the amount of oxygen. So why it is so? Because the equation is H2O gives H2 plus O2. But this was a skeletal equation, and once we balance this equation, it comes out to be 2H2O gives 2H2 plus O2. Right? So according to a balanced chemical equation, 2 moles of water, they break down to give 2 moles of hydrogen and 1 mole of oxygen. So hydrogen and oxygen are formed in the ratio of 2:1. So they collect also here in the ratio of 2:1. Now the next question is, how will you identify the gases in the two test tubes? So if you pull out this test tube and bring a burning splinter to it, so it is going to burn with a pop-up sound. Hydrogen burns with a pop-up sound. And oxygen, if you bring a burning splinter next to it, it starts burning more because oxygen supports combustion. So this is how burning splinter here will start burning more vigorously. Start burning more vigorously. So this is how we identify the two gases. So remember, these are the permanent questions in the first unit test which you are going to appear for. Why do we add few drops of dilute H2SO4? Name the gases released on cathode and anode. And why the amount of hydrogen is double the amount of oxygen. If you are not able to follow it, it is according to a balanced equation. 2 moles of water gives 2 moles of hydrogen and 1 mole of oxygen. So the amount of hydrogen is double the amount of oxygen. So this is all for today. Thank you all and have a lovely day.